So our learning goal today states, I can describe how changing the slope and or the y-intercept affect the graph of a linear function. So we are going to be doing, it's called transforming, and we are only going to work with a limited number of the transformations. There are more transformations than we're going to work with, but they keep it pretty basic in Algebra 1 class. They're going to extend you in advanced algebra class. That's where you're really going to have to put your thinking caps on, okay? So a set of functions whose graphs have very basic characteristics in common. So you have this set of functions. They have these basic characteristics in common. They are a family of functions. They make a family. So all the linear functions, because they have the same basic characteristics, give me some characteristics of linear functions. Ronnie, what would you expect from a linear function? What kind of a graph would it have? Oh my goodness, how in the world are we going to take a quiz this Friday and pass it? What would the graph of a linear function be? Linear, what I'm looking for is in that word. It would be a line, thanks Morgan. Oh, seriously. There would be a line. All linear functions should result in a graph that is a line. Can you think of anything else?
It's going up at a constant rate.
Okay, be going up or down at a constant rate. So when we have linear functions, they form a family because they have those same basic characteristics, and they all have the same basic graph, which finally Morgan was able to tell us is a line. So if you have a line on a graph, its equation would fall in the linear function family. Unless it's a vertical line. Why wouldn't a vertical line fall in the linear function family? Why are they the black sheep? Why are they not in it?
Well, because it's not linear.
Well, it's linear.
Because there's multiple y values for the one x.
Oh, there's multiple y values for the x value, so it's a line, but it's not a function. It's not a function. That's the thing. Okay, so the most basic function, every family of functions has what they call their most basic one, and they are called the parent function. They're the ones from which all the other functions derive. For the linear functions, that is f of x. What's f of x the same as again? Y. F of x equals x, or in other words, y equals x. That is the parent function for the linear function family. It's the most basic. So tell me something about that. What would we expect that parent function to look like on a graph? Where would it cross the y-axis? At the origin. Because the b value is what? 0. Tell me something else about it. Would it rise from left to right? Would it fall from left to right? What would it do?
Rise from left to right.
It would rise from left to right. Okay, at what rate? Constant rate of what? Of 1. So as you rise 1, you would run 1. Okay. Would you, excuse me, right now, we'll put that in your graphic calculator. Go to y equals, clear out anything that's in there. Pop up to those plots. Remember, I think we were using plots yesterday, so I'm guessing that plot 1 is darkened right now, where you turn it off by getting up on it and pressing enter. It should unhighlight it, turn it off for you, clear out any equations that are in there. And let's type in y sub 1, just an x. Let's put the parent function for the linear family. And then do a zoom 6. This is the only time we should have to zoom 6. It is to go to standard every time now after this, okay? Does the line do what we predicted it would do?
Yes.
go to the table, and let's make sure it's changing. As the x's are changing by 1, so are the y's. Second graph takes you to the table. Is it going through the origin, 0, 0? As the x's change by 1, are the y's changing by 1? Or better said, for slope, as the y's change by 1, are the x's changing by 1? Yes, okay. So this is what we call the parent function of the linear family. So when you have to graph this in your homework, when you have to graph the parent function, that should almost be a no-brainer. It should be like, okay, I'll just start at the origin and I'll just keep going up, 1 over 1, up, 1 over 1, down 1. It should be pretty easy, become pretty rote to be able to graph it. So the graphs of all other, will you just turn that off for right now? You can leave that in there, just turn it off. The graphs of all other linear functions are transformations so all other, wrote right over the word of, transformations of the graph of the parent function. So the parent function started the whole thing, and every other linear function has been derived from it, okay? So the 3 types of transformations of that linear function that we're going to deal with in this course are translation, rotation, and reflection, okay? What's a translation also known as, aka?
A parent.
No? A slide, yeah, it's a slide. Every point moves the same distance. So you have this line, you have the parent function, y equals x. Every point on that line moves the same distance and the same direction, and it's just a slide. So we'll leave it, and we're only going to deal with slides up and down. We're only going to deal with vertical slides. You do not have to deal with horizontal slides in Algebra 1. Doesn't mean that there aren't horizontal slides, we just don't have to deal with them. We are only going to deal with the vertical ones. Rotation, what's the AKA for that? What do you think of when you think something rotates? What's it do? It turns, so we will call it a turn. Well, what would turn a line? The slope would change, right?
Yeah.
But what wouldn't change? The y-intercept wouldn't. So when it turns, it's going to actually turn right there on that y-intercept. Every other point is going to move to a new location, but the y-intercept is going to stay where it's at. Reflection, what's that also known as? A flip. So when we reflect something, we flip it over a line, we have a line of reflection, and it produces a mirror image. Okay, let's explore a little bit more what actually makes those things happen. So, for a vertical translation, what do you think changes and what does not? So think of it, a slide up or a slide down. What would change
The x-intercept. No.
and what would not change? With regard, remember our learning goal says, describe how changing the slope and or the y-intercept affect the graph. So, if we're going to slide the line up or slide the line down, what would change and what would not? The y-intercept would change. What does not change?
Slope.
The slope does not change. So, if we have an equation, and then we have a new equation, and the only thing that changed was the y-intercept, we'd be able to say there was a transformation of a vertical translation. And we'll just say translations today, okay? For a rotation, what changed again? We already said it. What changed in the rotation?
Slope.
The slope. Does the y-intercept change?
No.
No. So the slope changes. Well, when we talk about rotations, we have to talk about the fact that, yes, it does rotate, but we also have to talk about what point does it rotate about. It's going to be the y-intercept. That's the fixed point. And what happened to the line? Did it get steeper or less steep? So what makes a line steeper? The smaller the slope, the steeper it is. Is that what we learned?
Yeah.
Okay, give me an example. If I say, give me an example of a line that would have would be steeper than the parent function.
Positive
Positive what?
10.
10. I thought you just told me the slope got smaller though.
That's what I said. That's not.
That's not what you said though, that's what other people said?
Well, I said it too.
But now you changed your mind?
Yes.
Oh, okay, well, let's try to make sure I got everything straight. Okay, well then a smaller slope would be what? Then the slope of the parent function is 1, so what would be a smaller slope? Is -1 a smaller slope? It is, but we don't talk about the actual slope, we talk about its absolute value, remember? How far away it is from 0. So would a slope of -1 really be steeper? No. What would it be?
The same.
It'd be the same, just going in a different direction, wouldn't it?
1 over 4.
1 over 4, okay, 1 over 4, so if we had a slope of 1 over 4, would that be steeper than the parent function?
No, it'd be less.
No.
It'd be less steep?
Yeah.
Let's go check it on the graphing calculator. What do y equals, and put, in y sub 2, let's put parenthesis 1 divided by 4, parenthesis x, and you know what, let's not change the y-intercept, let's just leave it, let's just change the slope, because we're kind of testing out the waters here for rotations. Graph, 1,
It's less.
parenthesis, 1 divided by 4, parenthesis x,
It's
graph.
less. It's less steep.
It's less steep?
Because you rise 1 over 4.
Yeah, we're rising and less than we're running, so it's less steep, isn't it?
Yeah.
Okay. Well, let's check out Devin's. He said, go to y sub 3, put in 10x. He says, I want a slope of 10.
It's way steeper.
Is it way steeper?
Yeah.
Yeah. It is, isn't it? Okay, so what are we going to say here? For a rotation, the larger the absolute value of the slope, the steeper the graph. Yeah, the steeper that line's going to be. And when we describe rotations, we have to talk about the steepness compared to what it was before it rotated. And then the only types of reflections we're going to deal with are across the y-axis. Show me the y-axis with your arm. Okay, yeah, we're going to reflect across the y-axis. It's going to go from one side of the y-axis to the other side. Doesn't matter which side it starts on, it just is going to be a mirror image over to the other side. So if it's a mirror image, what's going to happen to a point that starts out on one side of the y-axis and is reflected across the other side of the y-axis? What's going to be true?
It's going to get opposite.
It's going to be the opposite
Yeah.
x value. It's going to be the same distance away from the y-axis as the point that was reflected is, right? Okay, so that's the only type of reflection we're going to talk about. Well, how are we going to get that point, or every point on that line, to jump across the y-axis to the opposite side? Same distance. How are we going to make that happen? What would make that happen?
It's opposite.
Multiply by its opposite?
Yeah.
Do we need to create opposites?
Yeah.
How could I create the opposite of 5? That's a reciprocal. How could I make the opposite? What is the opposite of 5?
-1.
Well, how could I make 5 a negative 5?
-1.
Multiply by -1. Yeah. So if the slope has been multiplied by a -1, or in other words, if the slope just changes to its opposite. So let's go do that in our graphing calculator. So you clear out your y sub 2 and your y sub 3. Clear out your y sub 2 and your y sub 3. Leave it in the parent function. Parent function, stick around. And in y sub 2, I want you to reflect the parent function. So what would you have to do?
-1. So -1.
So negative x. Because 1 times -1 is -1, so we would just change the slope. And when you press graph, what happened?
Makes an X.
Makes an x, so isn't it just a pretty picture? Did it flip it over the y-axis? It did, didn't it? Okay. So, these are the types of transformations we're going to have to deal with. So again, what do we have to focus on? What are the two things we have to focus on? The slope and the y-intercept. Okay, the slope and the y-intercept. So you turn that off for a little bit, and let's go to the back side, and let's start seeing if we can, without the graphing calculator, just tell what transformation would have occurred from the graph of f of x to g of x. Now, g of x is really the same as y. It's just, they're saying we have function f, we have function g. We have two different functions. Both of them can be replaced with y's. So we really have here y equals x and y equals x minus 4. So tell me what f of x equals x is again? What's that called? The parent function. What is, I mean, without even hardly having to think, we were always going to say the slope of the parent function is 1. The y-intercept is 0. Write those down. Because every time before we describe a transformation, we're going to have proof of our transformation. Well, how about the g of x? So in other words, now the parent function has been transformed. So what's its m value, its slope? It's still 1, isn't it? It's just an x. What's its b value? Okay. So we're going to look for changes. Did the slope change? No. Okay. How about the y-intercept?
Yeah.
Okay, let's circle that. So the y-intercept changed. So which of our transformations changes only the y-intercept?
Translation.
A translation. And when we talk about a translation, we're going to talk about up or down, so direction and distance. So what happened to the parent function? Its y-intercept is at 0. The new function, the transform function, is at -4, its y-intercept. So what happened? It was translated down 4. So if we graphed this transform function that just translated down 4 units, if we graphed that with the parent function, what would you expect there to be on the graph? First of all, there should be 2 lines, don't tell me that. But what could we expect with regard to these 2 lines? Devin?
They're parallel.
They gotta be parallel, right? Why?
Because the slope's the same, the
Same
y-intercept.
slope, but different y-intercepts. The only thing that changed was the y-intercept, therefore they are parallel lines. The slope stayed the same. Okay, you go do number 2. M equals B equals for both of them. And when you start feeling like I've written M equals 1, B equals 0 a million times, then you're doing what you should have done. Well, then, if you're feeling like a real smarty pants, go ahead and do number 3 too. Let's see if you can get that one. Okay, take a look at number 2 if you're done with 3 and see if you need to fix anything on mine. Did I do anything wrong? Do you agree with me? Yeah? What's true about one of the functions in number 2? What can you say? One is the parent function, okay. How about number 3? Is the parent function involved in number 3?
No.
Oh, well, what does that mean happened then? If neither of these are the parent function, then that means one of them came from the parent function, and the other one got transformed from that new function, didn't it? Because remember the parent's the beginning, right? So f of x must have come from a transformation also. But we don't have to describe that transformation. We have to describe what happened from f of x to g of x. So what is the slope in f of x? Okay, what's its y-intercept?
5.
Okay. What's the slope in g of x?
1.
Okay. And what's its b? Its y-intercept?
-2.
Okay. So what transformation occurred here?
It translated down 7.
It translated down because the y-intercepts are different. Okay, so it translated down. And where in the world did you get 7? And also, by the way, why is it down?
It goes from positive to negative.
It went from a positive y-intercept to a negative y-intercept, so it had to go down. And how do you get 7?
Well,
It
because
takes 7 to get down to -2.
Okay, so from 5 to -2, there are 7 units of distance? Yeah, so translated down. So this takes care of the negative part, doesn't it? Going down, and then it translated down 7 units. What could we expect in all 3 of these situations on a graph? You better have parallel lines when you're done. So in your homework, note that some of them you have to graph to support your answers and to also give you a visual of what would be happening, okay? So questions on those? So a translation occurs when what?
the slope.
When the slope stays the same and the y-intercept changes. Okay, so the only thing that is affected by a translation is the y-intercept. Okay, let's look at number 4. Again, we are going to identify slope and y-intercept every single time. Oh, good old parent function, I like that one. I've just got that one in my like. Don't even have to think hardly. G of x, what's its m? G of x, 1? 4. What's its b?
0.
Okay, anything change?
The slopes.
Slopes did. This time just the slopes?
Yes.
Okay. Well, if just the slopes change, there's the 2 r's we're going to look for. Either a rotation, just a rotation occurred, or a reflection and a rotation occurred, or just a reflection occurred.
Just a rotation.
How will we know if it's a reflection?
It would be a negative.
They would be, the slopes would be what?
Minus.
Opposites. They'd be opposites of each other. So are these slopes opposites?
No.
No.
Okay, then throw reflection out by itself anyway. What's another thing that could possibly indicate a reflection?
The y-intercepts there.
Stick with the slope. If one of them is positive, the other would have to be negative. To reflect over, would not have to happen. The slopes would have to change to the opposite sign. Okay, so we'll explore that a little bit more in a bit. But the only thing that happened here is we went from a positive 1 slope to a positive 4 slope. So what transformation occurred? Okay, so we're going to say it rotated. But we don't get to just say it rotated. We get to say about what fixed point. In other words, which point is going to stay fixed on this? 0, 0, the y-intercept. So rotated about 0, 0. And is, we talked about its steepness. Did it get steeper or less steep? It went from
Steeper.
1 to 4. It got
Steeper.
steeper and is steeper. So all of those things are important in the description of our transformation for a rotation. It rotated. What was the fixed point? Did it get steeper or is it less steep? Okay? Question?
It can't translate.
Okay. It could translate along with the rotation, but did this one translate?
No.
How would we know? How do we know this one
The
didn't translate?
y-intercepts.
Because the y-intercept didn't change. Okay, so the only thing that happened is the rotation this time. Okay, you try number 5. Okay, how do you feel about this? Do you agree with me that the only transformation that occurred is a rotation?
Yeah.
Okay, well if it rotated, it has to rotate about a fixed point. What's the fixed point going to be? 0, 0, so this point right here is, so it's rotated about the y-intercept. So rotations, we think, typically what we want to do is think about rotations happening first. So that we'll rotate first if that's, and in this case, it's the only thing going on. So we don't have to worry about it first. And it went from 1 to 1/3. What would you expect on the graph? Would the new line be steeper or less steep?
Less steep.
Is less steep, yes. The slope's absolute value got smaller. So the smaller the absolute value, the more it flattens out, right? Okay, how about in number 6 then? What's going on there? Do we have the parent function? No. So our f of x has already been a transformation from the parent function, but we don't care. We're going to start with this one. M equals 3/5. B equals 0. Our transform function, m equals 7/3. B equals 0. What do you think? What happened here?
Rotation.
Okay, why?
Because both of the slopes change.
Only the slopes changed, and they're both what sign?
Positive.
They're both positive, so we know a reflection didn't occur besides. Okay, so we have a rotation. So rotated. So we're talking about this one right here, f of x. F of x rotated. What else do I have to say? About. What's the fixed point? So we look at the y-intercept of this one. It rotated about 0, 0. Now, don't get in the habit of thinking it'll always be that rotation point. It will always be 0, 0. You have to pay attention to the y-intercept, okay? And then what happened to steepness?
Steep.
It gets steeper.
Why?
Because
Well,
the number
because
is
it's
bigger.
bigger.
Because 7/3 has an absolute value bigger than 3/5, okay? And is steeper. Okay, I want you to put that in your graphing calculations really quickly, and I want you to see we'll clear out anything that's in there, and you know how these wonderful fraction ones you put in. I want you to put in the 3/5 x, you know how you have to put 3/5 in as a fraction. And then in y sub 2, put in your 7/3 x. And just press graph.
Do we keep the parent function on the graph for this one?
No, clear that up. Are they both going the same direction?
Yeah.
Yeah. Can you tell which one is which?
Yeah.
How do you know?
Well, because
Steeper one
the
is
steeper ones.
7/3.
Oh, yeah, but are you sure?
Yeah.
I mean, we just think that's the case, right? Press the trace key and let's see if it'll help you out. Make sure. I want you to verify. So when you press the trace key, do you see like something flashing on one of the lines?
Yeah.
And somewhere on the screen, does it show you the equation? Yeah. Okay. So are we right? Is the steeper line the one that is 7/3 x? You're looking at me like you're really not
Yeah,
getting.
mine deleted.
Oh, you deleted yours. Okay. Help me out here, Josh. So see where it says up there, and that's the steeper one, isn't it? Cool. Okay. Are they intersecting at 0, 0?
Yeah.
You know. Okay, why?
Because that's what the rotated.
That's what it rotated around. And did any other transformation happen?
No.
No, that's the only transformation that happened, so that should be their point of intersection. Okay, let's look at number 7. Go ahead, turn those up again. Every single time, I don't care how sick of it you are going to identify M and B for both of them. So this one's the parent function. 1, 0. How about G of x?
-1, 0.
-1, 0. Okay? What changed? The slopes. And they are what of each other? Opposites of each other. So what happened?
Reflection.
Reflection. Reflected. And we're just going to stay with this thought. Where did it reflect?
Over the y-axis.
over the y-axis, reflected over y-axis. Because there are other, well, I shouldn't say there are other types of reflections. Basically, there has to be a line of reflection, and our line of reflection is the y-axis, okay? Okay, let's look at the next one then. F of x, is that the parent function? Negative 1/2 x? No, doesn't matter though. Or transformation occurred, or transformations, if there's more than one.
Reflection.
Just a reflection, that's it. How do you know? The slopes are what? Opposites of each other. Reflected, and what's it reflected over? Y-axis. It has to have a line of reflection. Okay? Okay, how about number 9? First thing we're going to do is we're going to identify what again? The m and the b's. Just go ahead and do it for both functions. What's the case here?
Okay, there's two of them.
Yeah, because both the slopes change and the, okay, so when that's the case, let's deal with the slopes first, okay? So let's deal with the fact that we have m equals 2, we have m equals -2, and decide, do we have both a reflection and a rotation? Just a reflection, just a rotation?
Reflected and translation.
No, I'm talking about the r's, the slope. What do we have?
Reflection.
Just a reflection, okay? So we start there, reflected over, which axis? Y-axis, okay. So was there any rotation? No, okay. How about, you said there's a translation? Because why? Yep, the y-intercepts are different, so we're going to say it translated. We haven't done that one for a bit. What do we have to say when we talk about it translating? Up or down, what did this one do? Went from -1 to 3, so it went up. And it went up how many units? It went up 4 units. From -1 to 3 is 4 units distance. Anything else happen then?
No.
Okay? Then let's take a look at number 10. First thing you're going to do, AJ, is?
M and B.
Thanks, AJ, aka Devin. Okay. Zero in on the slopes first. Slopes change?
Yeah.
Okay. Well, then we're going to look at the 2 R's. First R is reflection. Was there a reflection only?
No.
Why not?
Because it's not the opposite.
They're not opposites of each other. One would have to be -1/4, the other +1/4. One would have to be 1, the other one -1. That's not the case. Okay. But what is true? Do they have opposite signs?
Yes.
So that means a reflection still happened. Because for one to become positive, one start out negative and for it to become positive, that means a reflection happened. So we're first going to talk about the fact, you know what? If this did reflect. There is a reflected over y-axis. But it also did the other R. It rotated. Okay? So it rotated. And when we talk about a rotation, we have to talk about it as a what? What else has to be included?
Or turning around.
The fixed point and the
If it's steeper or
steepness.
less.
Okay, so this rotated about what?
0.
0, 0.
Yep, go to this one's y-intercept. Go to this one, 0. It's 0, 0.
Sure.
And is what?
Steeper.
Steeper. So the absolute value of these two, one is larger absolute value, so it got steeper. Okay. What else happened?
Got translated down.
Okay, that took care of the slope. Now we look at the y-intercepts and say, hey, these guys are different too. So that means we had a translation, and we have to talk about direction, up or down? 0 to -2, down. How many units? 2. There was a whole lot of stuff going on in that one, wasn't there? So sometimes it can be all 3 of them. Questions? Lose you anywhere along the way there in that one? Okay, now we're going to be challenged to write, because you're going to do this in your homework. Write a function, so your new function is going to be called g of x, to describe the new graph. Oh, Devin's already got this for us.
G of x equals -3x.
Okay, so I'm just going to put it over here for a little bit until we check you out. Because what would be important to have from this to be able to accomplish what they want us to do? What do we need to know? Slope
The slope and the y-intercept.
and the y-intercept. Because now we get to see the transformations that they talk about us doing. We have to see which of those two do they have to affect and how do they have to affect them, right? So if we want it to reflect across the y-axis, what do we have to do?
Change the sign.
Okay, we have to change the sign of what?
Slope.
Slope. So the slope has to change to its opposite. So we need a slope of m equals -3. That takes care of that. And though we're not done, it has to translate 7 units up. What would that have to do? What would the b, that would change the b value, wouldn't it? So it goes from b equals -7, and we have to add 7 to that. That is 0. So we are thinking then that our new function with its slope of -3 and a b value of 0, do we need plus 0? No. Guess who's right? Deb.
Good job.
Okay. Whew, that was a lot of stuff. Okay. You need loose leaf because